On this episode of This Week in Space, we're talking about the dangers of orbital debris. Stay with us.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 119, recorded on July 12th, 2024. Junkyard in Space. Hello and welcome to another episode of This Week in Space, the Orbital Billiards edition. I'm Rod Pyle, editor-in-chief of Ad Astra Magazine. I'm here once again, finally, after weeks of time off, with my old pal, Tarek Malik, editor-in-chief of Space.com, just back from his globe trotting. How are you, sir?
I'm doing all right. I'm here for at least a couple episodes. So
I swear. Well, and you owe a debt of gratitude to Isaac Arthur, who came in and did a bang-up job behind you, so...
Yeah, he was great. Those you guys did such a great job, and it was so much. It was a very weird experience listening to the podcast and not being on it. It was really odd.
When I was off and I listened to the episodes you did, I thought, I feel hollowed out by this whole thing. Start worrying. Our guest, who will be with us in just a few minutes this week, is Dr. John Crassidis of the State University of New York, University at Buffalo. And he's going to be here to talk to us about the dangers of orbital debris, or as I like to call it, the "it's all over my head" problem. Get it?
I got it.
Now, before we start, I have to remind you and reprimand you if you haven't yet. Don't forget to do us a solid. Make sure to like, subscribe, and all the podcast things that you can do on your favorite podcatcher, because we need that. Now, we have a space joke from loyal listener Drew Logan. Captain Kirk said to Scotty, "Hey, Scotty, I heard you brought a couple of used engines at a yard sale where you were on shore leave." "Aye, Captain, it was an impulse buy."
I love it. The Starship engine joke.
Thank you, Drew. We couldn't have done that without you, although that might have been a good thing. But everyone, save the cosmos from us and our humor. That was a good one, but certainly save yourselves from me. And send us your best work, or worst or most indifferent space joke at twit.tv, and we'll give you appropriate credit or non-credit, as the case may be. All right, let's look at some headlines.
Yes.
All from space.com this week.
Yeah, I'm back
Falcon
now, so
9.
I get the pick.
Yeah, Falcon 9. Yeah, thank you. You stomped all my headlines. Falcon 9 launch failed, which almost never happens. What happened?
Yeah. So this is a really interesting one. It's actually happened late last night, and so I thought it'd be good to write about. But so SpaceX was launching their latest batch of Starlink satellites. I think they call it 10-9 or something like that. And during the launch, when they're going to restart the upper stage, something happened. Elon Musk said that they had an engine RUD for reasons currently unknown. RUD is SpaceX talk for rapid unscheduled disassembly. It means the engine exploded, right? Yeah, and so they're trying to figure out what happened. Now they did say that they had 20 or so Starlink satellites. They did say that they were deployed, but they're in the wrong orbit. The orbit's too low for like a regular flight. Then they had contacted, I think, 5 of them at that time, and they were trying to see if they could salvage them, but it doesn't look good for them. So the reason that I kind of pushed some of the other headlines that you had selected down is because they were talking about different SpaceX flights and whatnot, and everything is tabled now. The FAA is investigating this with SpaceX. This is the Falcon 9. SpaceX's workhorse rocket. It wasn't like a launch abort. They had an in-flight failure. They haven't had an in-flight failure of a Falcon 9 since what? 2015? Right?
Early on, yeah.
I mean, there was the NASA cargo launch loss, and then there was the pad explosion one that they had, the failure, and those are the two, right? So no launches, and SpaceX is 60 plus launches into the year. This is going to be a big hit if they can get the bottom of it quickly because they've been launching these Falcon 9s like what twice, 3 times a week. And they were supposed to launch the Polaris Dawn mission at the end of this month, July 31st. That's the Jared Isaacman flight with the private spacewalk. That's probably going to be slowed until they can figure out what's going on with this upper stage as well.
Now, the booster had probably been reused a bunch of times, but it's worth pointing out that the upper stages are not reused for obvious reasons. Yeah. So this wasn't a used engine. This was a brand new upper stage engine.
So I mean that's the first thing that I think about, right? When I hear about an in-flight failure, it must have been the old used booster. No, not the case. This brand new upper stage, something happened or while after they had gotten into orbit, that led to this failure, and they're going to want to know what caused that because these are new on every single flight. There was a lot of ice you can see in camera views from the engine. We don't know if that's part of the issue or not, if they had a leak or whatever, but we're going to find out more, I guess, as this investigation goes on.
And this was a Cape launch or Vandenberg?
I believe this was a Vandenberg Space Force launch. Yes.
Okay. All right, moving on. Tell us about the cosmic penguin. Because it's so cute.
Yes.
It's so cute.
This is another really really a recent one because it just got released today. So as you and I are speaking, Rod, we are celebrating the second anniversary of the James Webb Space Telescope's first photo that was released a couple of years ago. And in honor of that, NASA has released a new photo. It is their penguin and the egg. It is an object called ARP. I guess we can call it ARP, right? 142, and it's these two interacting galaxies that are about 326 million light years away, and it looks like a papa penguin pushing its egg along, in Antarctica. It looks adorable.
Share it for everybody. Aww.
Yeah. Aww. And it's not like it's a new object. It's something that we've seen before. It's in the constellation Hydra. But this was
what they had. Looks like a seahorse.
Yeah, I could see that too, or a hummingbird, right? But it kind of looks like that too.
What an incredible picture, though.
Wow. Yeah, and this is the most detailed view that we've ever seen of these interacting galaxies. And while it looks adorable and cute to us, scientists can get a lot of information about how galaxies interact with each other, how they change because of those interactions, and then how that could have lead to different types of star development and whatnot over time. And so it's really interesting. And of course, the fact that it's an adorable penguin just gets people super excited about what else James Webb can see. So yeah,
we are such suckers for anthropomorphizing things.
Things that look like other things are like one of my favorite things to write about at space.com. So
well, and the idea that because it's cute, it is necessarily non-fatal, and that's not always the case.
Yeah, and this isn't like this. This is, we're talking about a pretty violent crash between two galaxies that created this, and it's not like it's a fast thing. It's been going on between 25 and 75 million years. This is when it started, and it used to be like a spiral shape galaxy, and so now this is what we've got.
Wow. Well, let's hope that doesn't happen here. And hey, it's time. Drum roll, please. Actually, we should have like goofy carousel music. It's time for the Starliner update. When will Starliner come home?
Yeah, when?
Starliner, come home.
When? NASA and Boeing still don't know. There was a press conference on Wednesday of this week that where NASA, and I quote, NASA's Steve Stitch says, "We're taking our time on the ground to go through the data before we decide on the return opportunity." So they're still waiting right now. And it doesn't seem like it's an issue about the thrusters or not, that the reviews are done. They're just waiting to kind of get through a few other things that are going on. There's a lot of traffic at the space station. The astronauts are helping out a lot by performing extra tasks and whatnot while they're up there. And while Boeing still wants to know like what caused the helium leaks and the thruster problems, they just haven't cleared it for departure yet. So That's the latest. You know, the astronauts, though, did have a press conference, Sonny Williams and Butch Wilmore, where they said they're really confident in the spacecraft, which is nice to see, and that they're pretty sure that it would get them home. NASA has said repeatedly, and Boeing, that if they had to leave because of an emergency or whatever, they could leave on the spacecraft today. So they're not too worried about that. So, but it's just weird that, you know, every week there's another delay. You know, they just keep saying that they're not going to say when. Now, from this briefing, Boeing and NASA do say that they're looking at like the August timeframe, like mid-August, like that's kind of at that 45-day target or whatnot for it. But they're not going to pick a date at this point in time. There's another flight that's planned, though, the Crew 9 Falcon launch to develop a new crew to the space station. That, you know, that timing, they wanted to bring them down before Crew 9 gets there because that's another 4 astronauts. So you're looking at that kind of weird traffic schedule. That Crew 9 launch, though, like we just talked about, could be disrupted by the investigation into the Falcon 9 launch failure too. Yeah. So there's a lot of moving parts right now about all of these things that we're trying to see how they fit together. Now, I will say though that oh, sorry.
Go ahead.
I was going to say really quickly, it's just really important to keep in mind that Boeing eventually needs to have these Starliners stay on the space station for 6 months because that's an increment, an average increment flight. However, this was supposed to be an 8-day flight, and we're like, what?
Yeah, that test.
This is so, but you know, when Demo 2 launched and SpaceX's first crewed flight launched 2 astronauts to the space station, they ended up staying for 2 months. But that extension was always a possibility. That was only supposed to be like a week or so, and then they extended it, and those astronauts were glad as well to get the time on board. I'm sure Sonny and Butch are having the time of their lives, you know, planning for a week and getting to stay for a month.
Well, I think I have a name for the next spacecraft they send up, Boeing. We'll call it ILIR. Just indefinite launch, indefinite return. Since indefinite, actually, we can just call it indefinite since that seems to be associated with it. Okay, enough hacking. Very quickly from the mailbag, we got a very nice note from Zahir Mohammed, who attended the 2024 ISDC and listens to the podcast. And he says, "Greetings, Mr. Rod. I'm thrilled to hear that the National Space Society's Ad Astra magazine received the milestone of success by winning the Marcom Awards in 2023. And
congrats.
We just won a Hermes Award, too. Yeah. As a student, such achievements of NSS have inspired me to pursue my goal in the vast uncharted territories of outer space." He writes better than I do. "By reading your magazine, it is only feeding my curiosity more. Congratulations on your victory." And thank you, Zahir.
Thanks, Zahir.
I also want to thank Isaac Arthur for ably filling in while you were gone, which I think he'll be doing again because you're leaving again.
Yes, I got two more weeks.
Your globe-trotting life of leisure. And finally, tip of the hat to Joe Engle, Apollo and shuttle astronaut who died
X-15
just a couple of days ago. And most remarkably, X-15 pilot. And on my Facebook feed, I actually attached a link to a Substack post I did of a chapter I wrote in a book in 2014. So I've known Joe since, I guess, about 2012. And I finally got him to, I asked him over and over, I said, you know, you really should write a biography and blah, blah, blah. And it was typical of Joe Engle. He'd say, nobody wants to know about that stuff. And I said, no, we really do. Because, sir, you flew the X-15 and the space shuttle. Nobody else has that perspective. And he'd always kind of, you know, raise his shoulders and go, aw, shucks. And he really meant it. It wasn't false modesty. I mean, he was a very humble guy who had this remarkable career. And I was briefing the chapter I'd written as I was posting it. In that flight, so in his first X-15 flight, as he came back, he did the one and only barrel roll as he was returning back to the Edwards area. And he got called on the carpet for it because you don't do barrel rolls in the X-15 when you're coming at it Mach 2 or whatever it is by the time you're near the ground. But he looked at his commanding officer with a straight face, said, sir, I was just scrubbing off some speed. Which, you know, it takes a pair to be able to say that to your commanding officer when you're flying the X-15. He also flew, he flew one of the highest missions. During one of those missions, he was testing an automated guidance system, which, you know, this is the day of basically analog computers. So it was not very sophisticated. And he had to reset it. I think he said 26 times Now, if it failed once or twice, you were supposed to abort. But this was the X-15. These are X-15 days. And he's like, well, it's still flying. I'll just keep going. So he kept the flight up and concluded successfully. But he had to keep, with one hand, he's on the flight stick. And with the other hand, he's resetting this guidance computer. So it's a pretty amazing story. So worth checking out if you have a moment. All right. Stand by and we will be right back with Dr. John Crassidis from the University at Buffalo, State University of New York, to talk about orbital debris. Stay with us. And we're here with Dr. John Crassidis, Distinguished Professor of the University at Buffalo at the State University of New York. Thank you for joining us today.
Thank you for having me.
And we're here to talk about orbital debris. So I thought
Space
maybe...
junk.
Thank you, Tarek. You just restarted my heart. And I thought we've talked about it in episodes past, but it's been a really long time. So, John, if you wouldn't mind just sort of framing the problem for us, because it's a big and ever-growing one that I don't think gets enough attention and perhaps isn't taken seriously enough, at least not by the public. So if you just kind of frame the problem, then we could talk about some of the specifics.
Sure. So first of all, I have to define what orbital debris is. It's anything that's not useful. So it can be as small as a paint flake, or it could be as large as a unused rocket body that's just going around in space. The problem is that there's obviously many objects up there. Currently, we track about 40-some thousand objects, softball size or bigger. The big issue is they're moving very, very fast. They're going at 17,500 miles per hour. And the reason why is goes back to Newton. Newton imagined a cannon on top of a very high mountain. He shot a cannonball, hit the ground, and he thought about, okay, if I shoot it further, it's going to hit down further. If I shoot it faster, it can keep going. And he asked himself an interesting question: at what velocity do I have to shoot this cannonball so it never hits the ground? And that's 17,500 miles per hour. And that's where gravity came from. So anything slower than that, the Earth's gravity is going to pull it back in. That's what we need to achieve that velocity. So when you see astronauts floating in space, you shouldn't think of them as floating. You should really think of them as falling at 17,500 miles per hour, but never hitting the ground. And the problem is that there's different types of orbits. So I always like to use the car lane analogy. So if I have two cars, one behind the other, same orbit, let's say at 17,500 miles per hour, not a problem. But there's different types of orbits. You can have something going around the equator, for example. In a worst case scenario, you can have a little piece of debris going around the pole. So that's a T-bone intersection. So imagine two cars colliding at a T-bone at 17,500 miles per hour. That's a very violent collision. And we're very worried about that because that can cause more debris, which collides with other debris and causes us some big problems.
So I think for a lot of folks, their introduction to this whole conversation may have been watching the movie Gravity, which was a little on the dramatic side, but it did introduce most of us to the Kessler syndrome, which is, I think, part of what you're alluding to there. But just to take a small step back, I think, and again, we've talked about this a bit, but when you're talking about orbital debris, and you sort of, you address this, but you're talking about rocks and ice that's left over from the formation of the solar system. You're talking about exploded rocket stages. You're talking about anti-satellite weapons tests, which leave huge clouds of debris. We're talking about bits of ice that may have come from fuel venting from a rocket. And as you said, paint flakes, which we've noted on the show a number of times. It was a paint flake no bigger than the size of a dime that just about took out the first panel of 5 of the front window, one of the shuttle orbiters, and so on and so on and so on. So at these speeds, it doesn't take much to cause major damage. So if I read my ancient physics education correctly, even something the size of a BB, if it's moving fast enough, can puncture an aluminum hull, correct?
Exactly. And that's a problem. And I'm most fearful of astronauts. So going back to gravity, yeah, that's a scary situation, but it's all momentum, right? Momentum is mass times velocity. So if you have a large mass and small velocity, you can have a lot of momentum. Train, for example, you can have a very small mass, a lot of velocity. That's the case we have in space. That can cause a lot of damage. So the Kessler syndrome is something we can get into, but it's something I'm very worried about. I think if we don't fix this problem and get on top of it, at least try to slow down the growth to have science and the technology catch up to be able to take out debris, I truly believe in 50 years from now, we're going to be in Kessler syndrome.
Well, John, I wanted to ask just about that timeliness part of it, because just overnight there was a rocket failure, like trying a SpaceX rocket that failed while trying to launch like a whole bunch of satellites, Starlink satellites in orbit. They said that it had an RUD, a rapid unscheduled disassembly of an engine during a relight, which to me just screams more debris up there right now in a really busy area. And then we've been seeing a bunch of reports of other junk just falling back to Earth. I think in Saskatchewan, there's a report out this week from the scientists that are studying SpaceX debris there. In North Carolina, near one of my writers' homes, he can go see a piece of a Dragon trunk that just fell out of the sky there. I mean, is the Kessler syndrome like not happening now? I mean, it just seems like we're in it right now, where we see all of this stuff just falling out of space or blowing up in space. In fact, there was just a recent satellite breakup event or explosion too that sent the astronauts you just mentioned in shelter for a short amount of time.
Right. So no, we're not in Kessler syndrome right now. Kessler syndrome is the situation where if you put up a satellite or anything, say humans have to navigate the debris field, where they won't be able to do it without the probability of collision being so great that it's not worth it. So that would make low Earth orbit, essentially what we're focusing on right now, useless. And right now, low Earth orbit is not useless. I think the biggest problem is we haven't had that many events. I mean, you mentioned these, and I think the one interesting one is the battery that came down through the person's house in Florida, right? Mm-hmm. Trying to get some money from NASA, and they should get some money from NASA, honestly. Because NASA, I used to work for NASA. I love NASA, but sometimes they make mistakes. But yeah, the stuff coming down, that's starting to become more prevalent. So that's becoming an issue as well, too. Some countries, China especially, is not doing a very controlled manner to have them come down, the rocket mm-hmm. bodies. We do a much better job at that. Sometimes we mess up, as I just mentioned, but it's not the stuff that's coming down that we're really worried about. There have been some documented cases where actually hit a human, but nobody's actually been killed yet. I'm more worried about what's going to go on in space itself. So everything low Earth orbit, there's still air molecules up there. There's still drag. These satellites will eventually come down because of drag and all the debris. You mentioned missiles. When China blew up one of their own satellites, it caused about 2,000 pieces of space debris. And that debris is all over the place in terms of altitude and inclination. And also 6 months later, the Terra satellite had a 7% chance of colliding with that piece of space debris. So that moved. Anything greater than 1 in 10,000, we will send up a message to somebody and say, hey, you should probably move. So there have been instances. Iridium Cosmos really sent a message up when those two satellites collided. They did not meet that 1 in 10,000 threshold, by the way. So I like to say they won the bad lottery. That's not a message that we're not tracking these satellites as best as we can. It's really modeling where they're going to go because we don't see them all the time. But there haven't been enough instances yet to really give us that scare that we need. And unfortunately, like a lot of things that we do, we're going to pawn this off to our kids. So when I give presentations to junior high kids and college kids, I tell them, unfortunately, you're going to have to solve this problem because we're doing the classic thing of on and off to our kids. And unfortunately, that's what's going on. And we'll see where all that goes.
Yeah, and just a quick follow-up, because you mentioned a couple of things there that I think we want to highlight. That Chinese anti-satellite test, that was a 2007 test where they destroyed a satellite, created vast cloud of debris. That is a problem that we're dealing with now. And of course, that Iridium Cosmos, I remember that vividly. That was that 2009 satellite collision that of two satellites in different orbits that like crashed, and then you've got these two streams of debris in different orbits now, which just seems horrible. And it's up there until it I guess the drag pulls it all down. Is that right?
Right. So that caused about 500 pieces of space debris. With those, so we have telescopes and radars that track these satellites. Unfortunately, we don't see them all the time. And even if we did, that causes other problems. I always like to say to freshmen, when an engineer tells you a piece of good news, first question you should ask is, what's the bad news? Because I've never had good news without bad news. So if you track stuff all the time, you would say, that sounds like a really good news. What's the bad news of doing that? The bad news is that I have to track a lot more objects, and that causes problems in what's called data association, because I don't know what the objects are a lot of times. So I have to give them a number, and then they pop up again. How do I know it's the same satellite? I'm tracking a lot of satellites, I could have stuff going like this, and I could misassociate those objects, and that's bad. So I think that's a space station when it really isn't. That's bad too. But we're not there anywhere near that point of persistent surveillance. We have to use exactly Newton's equations, same ones that he did with a little bit of a ballistic-like coefficient on there to handle disturbances, to predict where these satellites are going to go. And right now, to this day, it's still done like the 1960s. They assume that the shape is a cannonball. We know it's not a cannonball. And we use that to predict where the satellite's going to be. And unfortunately, with the Iridium Cosmos, that prediction was off. And that what led to that collision. And like I said, they won the bad lottery. As far as the Chinese ASAT, there's been some studies done by AGI that predicts that 80% of that stuff's going to be up there, even using a high drag model 100 years from now. So that's pretty scary when you think about that. And that's the problem. We're putting a lot more stuff up there than what's coming down. And so that debris field is growing in space. And again, if we get to that point where we have the probability of collision being so great, you have to take out insurance, for example. Uh-huh. Everybody takes out insurance. Nobody's going to insure you to build satellites. So that'll essentially render low Earth orbit, and that's going to cause a lot of problems.
We've often decried China for dumping rocket stages just down the block from their launch site, sometimes near villages and so forth. But I suppose, as you say, there's good news, bad news. The good news there is it's not becoming orbital debris. On that rather sour note, we're going to take a short break, and we'll be right back with Professor John Crassidis. Stand by. So, John, could you talk a bit about, you kind of touched on this, but how these things are tracked, what we can track, what we can't track, and what we do with that information? Because it's always been a bit of a mystery to me, I think. I know the Space Force is doing a lot of it, but I'm sure there are others.
It's mostly the Space Force, yeah. So we have dedicated sensors. Most of them for us are in Maui, but we have them all over the world. There's a big gap in Asia, by the way, and radars, there's a lot less radars than there are telescopes. But so we get hits on them, we can determine their orbits. The problem is we don't know, even when we have the sensor measurements, we don't know exactly where they are. So the analogy I always like to say is, I'm in a classroom, I ask the students to estimate my height to within a quarter of an inch. And you're going to get
that's really good. That is really good.
And I'm exactly 5'8" tall. So some people will be way off and say I'm 6 foot, and I'll be very happy. Others will say I'm 5'2", but most of them will be centered around there, but not exactly my height. And the same thing with any sensor. Any sensor is going to have that's noise. So even when we get hits on these satellites in terms of sensor, we don't know exactly where they are. The problem is, for a long time, like the upper stage of Apollo, we lost for like 20 years before it was rediscovered. Somebody thought it was something different, like an asteroid, but they did a hyperspectral analysis and saw it was paint. And that's how they identified it. I think it was Apollo 12. So we lose these objects we can lose them, especially if they maneuver when we don't see them. Because we're not just tracking our objects, we're tracking everything up there. And again, we have to rely on Newton's equation. And the problem with that is there's disturbances in low Earth orbit. There's the air molecules. We don't know the upper density really well. Again, everything's modeled like a cannonball. We know that that's not true. We don't know the shapes. That's a lot of part of research I'm trying to do, is try to determine the shapes by how the light is reflecting off of them. So that leads to errors. And even at high Earth orbit, we're a geostationary satellites, or a lot of our communication satellites, 22,000 miles up. There's solar radiation pressure. It's not solar wind, but you can think of it that way if you want. And we don't know that well. But what I like to say is that the smallest effect we can't feel in here has a big effect in space. So an example would be the Earth's gravity. So it's directly related to Einstein, who relates that to mass. The mass at the equator is actually bigger than at the poles, because the Earth is not a perfect sphere. So gravity is different at the equator than the poles. We're not going to tell if you stand on the equator, you stand on the poles, you're not going to be able to tell the difference. But that has a huge effect on satellites. If you try to fly two satellites in formation, that so-called J2 effect is going to move them around a lot. The drag has effects, solar radiation pressure. And so we just don't have enough accurate models to do what we need to do. And that's the That's the problem of why there's a lot of still uncertainty that leads to collisions, unfortunately.
So I just want to do a quick follow-up, and then it's Tarek's turn. Ownership has always been an issue here, too. I mean, in theory, the launching state owns, if I understand correctly, owns and is responsible for any fallout, quote unquote, from one of these objects. So if something falls back to Earth or slams into the space station and it happens to be a piece of Russian detritus, then the Russians are responsible. If it's ours, we're responsible. But how do you maintain that track of ownership, if you will?
Well, so to get into the catalog, so that's why there's only like some 30,000 in the Space Force catalog. To get there, what you have to do is show exactly where that object came back to launch. So a bunch of objects are up there that we don't know where they came from. But to your ownership question, yes, we take responsibility, but unfortunately, there are no international treaties. I mean, there's the 1967 treaty, which is obviously out of date, and there's been some newer ones. But the two countries, we know the ones. They're Russia and China. They could care less. If they were to do some damage, they're not going to take responsibility. We know that. We're trying to do better. So we have some rules that if you have fuel left, if a satellite has thruster, you have to have enough fuel left over to do a controlled deorbit over the Pacific Ocean. So just in case something gets through, no one would get hurt. They recently changed the rule. If you don't have a thruster, you have to show the drag. In the past, was going to bring it back within 20 years. Now they've changed that to 5. We're building a satellite right here for the Air Force, and it's not going to have thruster. So we had to convince the Air Force that we're going to get that satellite back within 5 years, doing all our model. So that's getting better. Still not enough to stop Kessler syndrome in my opinion, but we are doing some better things. What we need is that international cooperation, and that's just not happening, unfortunately.
John, I was curious if there is a difference in terms of like orbital debris and space object tracking between active satellites right now to prevent those conjunctions that you're talking about, those moments where they could, have the possibility of impact, and tracking the smaller objects down to a softball that aren't satellites. They're just like the remains or debris or whatnot. Or is it all one bag? Because I recall, I guess, what was it, back in 2018, there was a executive directive that I think that in Trump administration to try to find a better way to get the information between, from the Department of Defense, which is tracking everything, to these satellite operators to say, hey, you have to move your traffic for space traffic management so that you don't have these close calls over time. But I wasn't sure where any of that stood like right now. Are there two different efforts, tracking defunct debris as well as active satellites, and then finding a way to mesh that all together? Or is it one just big program that is trying to make sense of this mess that we've made in orbit? So
they're all put in one catalog, so they really don't separate them in that sense. Where the separation comes into play, so Iridium Cosmos is the example. Had they met that 1 in 10,000 threshold, then we would have called up Iridium, because that Cosmos satellite was defunct anyway, so it wasn't moving. So that's what happens is they will call and say, you probably should move. You don't have to, but you probably should move. Starlink is actually Musk is doing something very smart. He's automated that process. So he's getting that information sent to all the Starlink satellites, and they've got some smarts. I always like to say satellites are dumb. Mm-hmm. We control them from the Earth, and there's really no smarts on them. But Musk, with the Starlink constellation, has put some smarts on them to be able to maneuver away much more rapidly, which obviously is a good thing. So, but to your original question, they're pretty much treated as one entity. But and that probably a collision is done all the time. And once it meets that threshold, if they're active satellites, if one of them is least active, we'll call up those manufacturers.
So both in the, in the movie Gravity and other shows we see about this and the conversation we're having, we're talking primarily about low Earth orbit, where the space station is and where the majority of this material is. Do we have to worry about this in places like geosynchronous orbit, which is much higher at about 25,000 miles?
What about,
Yes, we
what about
do.
Mars?
Yes, I'll talk about the moon in a second, but so geostationary, none of those satellites are coming down, and so they put them in graveyard orbits a couple hundred kilometers away. We did a very detailed study for the Air Force years ago, where it was the most detailed simulation we think that anybody's ever done. So we're looking at 50 years from now. In 50 years from now, things like Jupiter's gravity is going to affect the geosatellites. So we put that in there. And we found out that some of these objects were going to come back into the geobelt. So we've been strongly suggesting that you should go out further than that. Haven't really listened to us, and that's fine. But Mars, yeah, right. Not Mars yet, but the moon, we're actually starting to see a little bit of space junk at the moon right now. And that's becoming very troublesome because we're taking our problems from the Earth and already starting to see that in the moon. I think the space age, right, started in 1957, not that long ago. Where are we going to be in 60 years from now, right? And considering what we're talking about right now and considering what we're seeing. I always like to say I don't want to be pessimistic. I like to be a realist. I know, but that realism is unfortunately pessimistic too.
Yeah, it wouldn't take a very high percentage of satellites from the Starlink constellation or the Kuiper constellation that Blue Origin is going to be coming up or putting up, or any another of that. Of course, the Chinese and the Russians are putting up their own as well. If a very small percentage of those even fail, you've got a seriously large, potentially cascading effect, right?
Right. And the early days of Starlink, they had a pretty high failure rate. That's gone down. So that's been an issue too. But we can't control what other countries do. And until we start to get... So my counterpart in China and Russia would actually agree with me, but I'm a low-level engineer, right? So I don't really have any say in it. But this is where we need to get our leaders together. But it's tough because we've got so many problems on Earth, and I get it. And like I said, we haven't had that many instances in space that it's really on anybody's radar screen, other than to say, yeah, we know it's a problem, but we got other problems to deal with.
All right. Well, we will be back with Tarek's next exciting question after this break. Stay with us.
John, one of the points you just made is how long we've been launching stuff into space, the space age with Sputnik back in 1957. And we've launched a lot of different types of satellites, different spacecraft, et cetera, all of them kind of casting off their fairings, their bolts, their rocket stages, et cetera. But I'm wondering, as things improved, are there types of those, like those early space age debris that are more dangerous now as they've been sitting up there aging in orbit or whatnot, or getting lost, like you mentioned, in the tracking, and that we don't know where they are, or is it just a matter that it's up there at all that is the challenge there? I think a lot about like the nuclear power.
Let him answer your question.
I'm sorry.
It's okay. No, it's just a matter of the objects up there. It's obviously, yeah. When you're talking about the fuels, they can be very dangerous and stuff like that. So if anybody does see a piece of space debris and it comes down on your farm or whatever, and you don't touch the stuff, you can be killed by it. But in space, no, it's not so much that. Most of the objects that cause debris actually are from exploding batteries. They come to an end of life and the satellites explode, and that's where the debris comes from. So there's definitely dangerous chemicals up there, and we put them up there. And but we're not so much worried about that because that stuff's mostly going to burn up in the atmosphere if it comes through.
So I know part of your work has been to look at remediation methods, ways of cleaning up the mess we've made. And there's a number of them that maybe we can work through, but do you have a preferred technique that you see in the future that might be most effective for bringing down or removing or repurposing this stuff?
Yeah, so there's another pessimistic viewpoint, unfortunately, but no matter what people are telling you, we do not have any technology right now that can remove debris. The Europeans, we're going to do some experiments. Anything that requires you to get close to debris, like using a grappling mechanism and pushing it back down to Earth, that's just not feasible. The analogy I like to say, I live in Buffalo. I can drive to Washington, D.C. and want to take a gas, get some more gas and go somewhere else. You can't move around space like you do on the Earth. You're fighting Newton and Kepler, and you're going to lose every time. So an example is, let's say I go pick up a piece of space debris, and I just want to do a little 10-degree change to go pick up another piece of space debris. That's going to require about 50% of my remaining fuel. So do I want to build a multi-million-dollar satellite that only take out a couple pieces of space debris? It's just not cost effective. But as I said, I talked about science fiction before, that today's science fiction is small as reality. And that's where I think we have to look at mitigation approaches, slow down the growth in particular. UN put guidelines out in 2010 on guideline, I think 4 says, don't make more debris if you can avoid it. Well, we're not even following that, right? With the ASATs that they're doing. As far as techniques, one of them we're looking at is, it turns out you can essentially have an oven in space and take some of this debris and make it into fuel. We're doing it a little bit different than everybody else. We're looking at high impact materials and have the debris come to us essentially instead of having to move around. But even if that, I mean, right now that's still, and there's lots of people actually looking at NASA's funding a bunch of this stuff. Even if that is a feasible approach, we're looking at least 20 years out before it becomes reality. So we need to buy that time. That's the crucial thing.
That's a really interesting point. And that's, I guess, where negotiation and international agreements come into place, right? Is to buy you that time to actually work with it. So just so I understand, because I never have understood this, if you've got a big chunk of debris that you're going after, do you have to effectively match orbits and speeds with it first so it doesn't come slamming into you when you try and rendezvous with it? Yes.
So rendezvousing is actually with an unknown object, essentially, that's not cooperative. That's actually a very difficult problem. We're doing a lot about it, a bunch of that research as well, too. I won't get into the details. I'll just say stuff. But yeah, first you have to match the orbital speed. But the other thing you have to think about, if that satellite's tumbling, so if I grab it, conservation of momentum, I'm going to start to spin as well, too. And I can cause myself to go unstable. If you look up the remove debris mission, they throw out a little piece of quote unquote debris, simulated debris. It was actually a real piece, but small. And he used the net to grab it. But you'll see that net was not tethered back to that little satellite. And the reason is the dynamics of that debris would go back to that satellite and possibly cause yours to go unstable. So there's a lot of dynamic issues that you have to worry about, not just getting there, but once you grab it.
So once you grab it, you really own it in this case.
Yes. And you own that satellite's dynamics, and you got to be able to handle those dynamics that are going on with it.
Right.
Yeah, that remove debris mission was really interesting because it was one of like a series of tests. I think there was one that had like a harpoon that they shot at a target to see how that would work, and then there was one for solar cells. But it just breaks my heart, John, that you said that none of them are really feasible now. You know, that whole space age future where we have all of these different little tractors in orbit, kind of cleaning and policing the lanes for litter. We're just not there yet, it sounds like.
We're not, and unfortunately, we're not going to get there anytime soon. But you brought up an interesting one of the solar sail. That was, I think it actually failed. I don't know if it really worked. So the idea is to increase your surface area to get more drag and get the satellite to come down earlier. That's something that is feasible. We can do that today. And I think that should be a mandate. So that would get the satellites down faster than 5 years. And that's pretty simple to do. So I think that's something we should look at.
So it'd be like a cape. You could build it onto your satellite, and then, you know, at the end of the life, you would just deploy that and then drag yourself out. What about those tethers? I think Rod mentioned this too. And I know that there've been some tests for that. The harpoon one was part of it. I don't think they had a tether on the harpoon at that point in time, but it sounds like there'd be stability issues there too. We've seen like just tether experiments in space that
well, why don't we explain what they do? Because I think that's a mystery to a lot of people. How does a tether work to deorbit objects?
Well, there's a couple of ways you can do this. So the harpoon one is interesting. I'm not a big fan of that because if it bounces off, you're going to cause that object to go somewhere else. So that's one I'm not a big fan of, to be honest with you. But the one that's looking at is to take a tether like a couple miles long and put essentially a big ball at the end of it and really cause a lot of drag in that ball and bring the satellite down really quickly. Neat idea. Do not have the technology to do this right now. I know professors that spent their entire career studying tether dynamics. And I think NASA did an experiment off the space shuttle where they did a mile long and it broke the crane, I believe. So that sent a huge message up that we don't understand tether dynamics. We're not ready to do this. And we have to do a lot more studies, analytical studies first, before we even get to some more detailed experimental ones. So that's another great idea, but just not feasible, unfortunately.
Yeah, I think JAXA did one too with an HTV, and it had the same result that you were saying there, where it got untenable.
Right. And huge message. We just don't have the dynamics knowledge to understand this stuff. And it's great that professors are spending their entire career, some of them doing this and trying to understand it, because we got to get some handle on it.
How do electrostatic tethers work?
It's basically the same concept, yeah. So that concept I just talked about is an electrostatic, where you can cause a voltage on it and get power. But that's just the interaction with the magnetic field and stuff like that goes on there to cause that electricity. But that's neat as well too. But it's more the drag that's going to be the thing that causes it to come back down. But there's my colleague is at University of Colorado, Dr. Hans-Peter Schaub, is looking at some form of that to, for lack of better words, do a tractor beam. So there's some neat stuff. So I encourage anybody watching this to go check out his research. It's actually some neat stuff.
So I'm not sure. No, I am sure I don't understand this completely. It sounds like what the tethers you're talking about have to be physically attached to the target satellite or piece of debris. I thought at one point I read about a tether system that actually, if deployed in sufficient length, would attract other objects to it and eventually slow them and bring them in. Yes.
And that's kind of the principle that Dr. Schaub is looking at. Yes, that's a neat one too. But you got to be able to control that, because when I give this talk to freshmen every year and tell them the problem, and then we let them come up with their solution, the one that always pops up is put a big giant magnet in space. And unfortunately, you can't do that. But let's say you could, you're going to attract everything, right? You're going to attract your active satellites and everything like this. So you kind of have to have that tractor beam approach where you just go after the piece of space debris. There's another idea of shooting a laser that can move small objects. The photons will move the object a little bit if you keep it up long enough. Again, not really feasible at this point, but there's lots of ideas out there. We can go all day talking about them, but unfortunately, none of them are feasible at this point.
Well, you mentioned my favorite, an actual tractor beam, which would be really useful, it seems like, for all of this stuff. I had a question about cleanup ethics from something you just mentioned about the difference between active satellites and defunct junk, because it dawns on me that any kind of remediation technique that you build to clean up space junk could also be used to go to a perfectly healthy satellite and do nefarious things to that. Are those challenges that also have to be addressed on that international stage to say this is what you can use remediation efforts for versus what you can't, be a good neighbor?
Yeah, so a lot of the stuff, unfortunately, I can't talk about, but because it's classified in nature. But I can tell you that I gave you an example. Russia has been sidling exosatellites. They've been coming close. So this is a problem. It's space defense is a big issue. There's space offense as well too. So nobody's done anything. What I can tell you is there's been an attack on our satellites every day. But wow. It hasn't been anything bad where they're blowing up our satellites. I'll say this more annoyance type stuff. But it's something we're very worried about, because we need those satellites, right? We need to understand what our enemies are doing. And if they start taking out the satellites by, let's say, laser dazzling or something like that, when we're trying to get critical information on a certain country and what they're doing, that could be very bad for us. So that's something that the Space Force is very worried about, and we have to be prepared for it.
So this is probably not a near-term solution to the orbital debris problem, but one conversation that comes up is how much money we've spent since 1957-ish sending mass up into orbit, especially with the space station, which is going to come down in a few years. And the discussion about, can't we put the stuff out into an orbital junkyard somewhere where it can be smelted and reprocessed and built into other things, which sounds a lot easier in the pages of a science fiction novel than it probably is to do, especially after the discussion we've had. But any thoughts on that?
Yeah, again, just not feasible at this time. I don't see that being feasible for the next at least 20, 30, maybe even 50 years, but who knows? Maybe somebody will make that great discovery to be able to do that. But until then, we've got to try to slow down this growth and not get into Kessler syndrome.
Yeah, because at this point, from what I last read, the estimate, which seems low, the estimate was 12,000 tons of man-made detritus up there. Is that the number you're familiar with? Okay.
Yeah. Again, it's not so much the mass; it's the velocity that we're worried about.
Yeah. All right. We'll be back with Tarek's next question in just a moment. Stand by.
I know we've been talking a lot, John, about debris. It's just in low Earth orbit right now, and you mentioned how we should be thinking about what we're adding around the moon. NASA has plans for the moon with Artemis. A lot of other countries have plans as well. We know even the Space Force has talks with their cislunar plans. But I keep thinking about that time Elon Musk launched his car into space, and that it's out there now. I think it crossed the orbit of Mars, and it's got the little Starman person behind the wheel, and how we've sent things out of the solar system too. And there must be space junk beyond our orbit that could pose an eventual hazard for astronauts who go to Mars, who go any other place in that far, far future. And I'm curious what people could do about that, because there's no one tracking that stuff, I would imagine. What kind of systems would we need to think about to detect and protect? Or is it just being ready to do damage control on your spacecraft if you're in interplanetary space and you find one of these things?
Yeah, so that one, I'm not worried about it at all, at least now. But who knows 200 years from now? But we're all not going to be around for that. But we were doing a bunch of research, so we won this. It was a big competition for a proposal called the Space University Research Initiative. And it has to do with cislunar dynamics, because the cislunar trajectories are a little bit chaotic once you look at 3-body effects. But we don't have a lot of situational awareness out there either. The Air Force isn't without their sense of humor. It's called the cone of shame. Anything within that cone, anything within that cone you can't see. So how do we get situational awareness? So we have some really smart minds looking at designing constellation near the moon, and to look at, there's some strategic points called Lagrange points. Physicists would know what they are. And we need to get situational awareness out there, because there are going to be some threats in the future out there, and we need to get ahead of that right now. So part of your answer is that putting more sensors up in moon right now, later on in Mars and other areas that are going to track stuff as we go and explore further and further out.
Yeah, so I think what you're talking about, part of what you're talking about, is there's a new system, and the name escapes me at the moment, that Space Force has been talking to NASA about deploying for cislunar traffic control and tracking, right?
Yes.
What's the name of that again?
They just recently changed it, so.
Oh, okay.
Yeah. But yeah, that's the point, is to try to get cislunar, and that has to do with a little bit more of the defense side of things, and China's doing some things out there. We have to be careful. Obviously, the things we do know about, they're landing stuff on the far side of the moon. It's not really the dark side, right?
Right.
But on the far side of the moon, and the big claims about that, who owns that real estate? That's beyond me, because I'm not a lawyer, but where does all that come into play? So there's various aspects that we have to keep on top of, and it's an unfortunate world we live in, but our adversaries want to outdo us, and we need to keep on top of that. And part of that is looking at the lunar area.
Now, speaking of adversaries, if I may, for a moment, we know that SpaceX has, I think we're closing on 6,000 Starlink satellites at this point, with limited maneuverability and control. Kuiper will soon follow with Amazon. But we also have China and I believe some parties in Russia looking at putting up these large constellations of satellites. Are we pretty confident in the West that they're going to be as carefully, hopefully, maintained and maneuvered as, for instance, the Starlink satellites are?
I'm not.
Well, tell us what you think.
Well, I at least from past experience, they just don't care. I mean, the Russians did an ASAT, and part of that, the astronauts and cosmonauts had to take shelter because a piece of that debris came pretty close to the space station. Mm-hmm. So that's some message I'd like to say to them is you're putting your own astronauts and cosmonauts in harm's way. Why are you doing this? I just don't understand it. It boggles my mind, but we'll have to wait and see where all that goes. But hopefully we can get people talking. But the realist in me says if it hasn't happened right now, I don't think it's going to happen anytime soon.
Is there a way forward to keep that conversation going through something like an orbital debris accords or an orbital debris license that agencies and companies, et cetera, would need to sign on to in order to just launch their stuff into space? You mentioned how the 1967 uses, the peaceful use of outer space treaty is kind of old and outdated in a lot of respects. We use space for a lot more things that we didn't even think of back in 1977, for example, or 67. So is that the way forward? NASA's trying to do it with their Artemis Accords. I mean, do you see that kind of platform?
Yes, absolutely. I think it starts at the UN guidelines. Go back to those and use that as a foundational document to get some treaties into place. One thing, I'm not a big tax person, but I think putting a tax on every satellite launch and putting it into a global pot to give to researchers to get that science fiction to reality a lot quicker, mm-hmm. I think would be interesting because NASA's. I love NASA, but they get picked on a lot for some reason. I don't know why their budget's so small. They don't have a lot of money for space debris removal research. And the Air Force is doing some, but they got their own mission, obviously, in the Space Force as well, too. So I look at it as a global issue. It is. A lot of people ask me, how does this relate to climate change? And I say, I'm not a climatologist. There's people that deny it. Nobody's denying that this is going to be a problem in space. So a little bit ahead in that sense that everybody agrees that this is a problem. So I think that's the starting point, to say that. We all know this is a problem. Let's put our differences aside. At least you want to do your warfare in space. Okay, we get that, but let's try to mitigate the debris problem so we don't have this be a problem for your children and our children.
Very profoundly said. And just a note on the NASA budget, in the 90s, there was still a fairly large percentage of the U.S. civilian population that thought NASA was eating up 25% of the U.S. federal budget. Last study I looked at, or last poll I looked at, had that number down somewhere around 8 to 10%. But it's 0.5%. So it's still exponentially off. John, have we missed any topics of conversation you think are important to cover? I mean, I appreciate you coming on and sort of sounding the alert on some of these things, because we have talked about orbital debris a few times before. But it's good to hear a warning from somebody who's as intimately involved in the actual research and the policy area as you are.
No, I think you covered everything really well. Great questions, by the way.
Well, thank you. Where can we go to get, well, before I ask that, do you have any new research projects coming up? Or are you about to publish on anything that you're able to talk about?
Yeah, we're publishing a lot, but a lot of my research is try to get an idea of what these debris objects are made out of. So we're looking at polarized light. We think that's something that's underutilized right now. And also, we're not the only ones to do this, but looking at what are called light inversion techniques. So just how light bounces off of objects, can we determine their shape and get a rough idea? So what we're trying to do is get a better idea of what these objects really look like. So hopefully we get better models. With better models, we'll get better predictions. With better predictions, we'll get better handle on that probability of collision. So we don't end up with something like Iridium Cosmos again. So that's eating up a lot of my time right now. It's exciting.
Just a last question, I guess. This is sort of a subjective one, but whenever you hear of another collision or another explosion, does a little part of your heart sort of sink, or is it just part of the game?
Every time, yes, it does. It was interesting. I had the Air Force here for a review when the Russian ASAT went on, so they were all flipping out, and and I was just like, oh, here we go again. Why are we doing this? It just boggles the mind why countries are doing this. So, yeah, it's for me, it's this. It's very. It's not as bad as when a satellite that I work on, it gets launched. You get that nervousness. Hopefully, what you design isn't going to fail. But what I think about is as a parent, we all think about our children, right? We want our children to have a better life than we did. And with this space junk, currently right now, we're not giving them a better life. We're giving them a worse life. They're going to have to solve this problem. So every time I see something like this, I keep thinking about our kids and our grandkids that are going to have to deal with this. And that bothers me a lot. And it should bother everybody.
Well, very well said. And on that depressing note, we should close. But I want to thank everybody for joining us today for episode 119 of This Week in Space, Orbital Billiards, I'm calling it. Don't forget the National Space Society is a good place to look for more information on this. Actually, we have a fairly large section on orbital debris. And of course, space.com, which is run by Dr. Malik. There on the screen.
Malik is my father.
I know you keep telling me that is another good place to go to keep current. John, where's the best place for us to follow your progress and research?
If you just do a search for my last name, it's very unique, so you will find me pretty quickly. Just do a search for Crassidis. Actually, right. The wino in Greek. My family was the only one that called themselves the wino. So,
seriously?
Yeah, my great grandfather was the town drunk, and my grandfather used that as our last name. They used to call him Crassidis. So
that is unique. That's amazing. Well, Tara could top that story, that origin story, if you will. Well, or just tell us where we can find you.
I think I'll leave that one there, but you can find me at space.com as always. In fact, on July 17th, please visit space.com because we're having a panel to celebrate our 25th anniversary. In 1999, July 20th, that was when we were founded, and we're going to have a panel about the next 25 years in space with some really big names: Sarah Seeger, John Mulhay. We had him on the podcast, and Tom Marshburn at Sierra Space astronaut talk about what we're going to be doing in space for the next quarter century on July 17th at noon, actually. And then, of course, you can find me on the Twitters or the X, pardon me, at Tarek J. Malik.
Well, I'll be carefully watching my email for my invite to your panel. And don't forget, don't chuckle. You can find me at pilebooks.com and at astromagazine.com. Please don't forget to drop us a line at your convenience at twis@twit.tv. That's TWIS at twit.tv. We always love to hear your comments. New episodes of this podcast published every Friday on your favorite podcatchers. So be sure to subscribe, tell your friends, and give us reviews. We'll take whatever you have to say quite seriously. Finally, don't forget, you can get all the great programming with video streams and other stuff you can only see on Club Twit by joining Club Twit. It's only $7 a month, and now is your time to stand up and be counted if you support podcasts, because it's getting tougher than ever to do these things. Finally, you can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook and on twit.tv on Instagram. Thank you very much. Thank you, Dr. Crassidis, and thank you, audience. We'll see you again next week.